Okay, today there's not a lot you have to do other than take some notes. We want to talk about schematic symbols today. Schematic symbols are the way you get a blueprint for some sort of electronic device. I wanted to have a nice simple device. We're going to use this thing in this person's right hand. What this does is it takes a signal from a phone and it broadcasts it to a radio station so you can listen to it on your car if you don't have Bluetooth or an aux cable. Okay, so this is what the schematic diagram looks like for that little device. And I just want you to understand what the different symbols mean and how to interpret this diagram. Okay, so what I'd like you to do in your notes today, nice and simple, just make yourself a really big table. It may take more than a single sheet. Try to put it on a fresh piece of paper so that you can use this during tests or quizzes once we get back to school. Okay, so for each component in your table, I'd like the name, the symbol, how you label it, and what the purpose of that device actually is. Okay, so the first device we're going to do is the simplest of all, wire. The purpose of wire is to carry the electrons from place to place, connect the different components together. Wire is just drawn with a straight line. You can have dots where two wires connect electrically. You can have little arches where the two wires overlap each other but don't actually connect to each other. And third, you can have an open circle, and that is where you attach some sort of external object to your circuit. So in our schematic, you can see lots of places where wires are joined together. You can see one spot where the two wires overlap without connecting, and you can see one spot where the wire is going to have a place to connect some sort of external device. In this case, our phone via some sort of headphone connection. Okay, so when you label this, again, it would be wire, the symbol. I showed you 3 different symbols, so try and put them all. The way wires connect, the way the wires overlap, and also the way you have for an external connection to your wires. Wires would be labeled with gauge, or maybe nothing at all if that's not important. And again, the description is the wires carry electrons from place to place in your circuit. The next device we have are DC power supplies. The symbol is a pair of parallel lines, one long, one short. You label it with a voltage, and the long line represents the positive. The description for a battery or a DC power supply is to give energy to your electrons, to power your circuit. You'll notice in this example we have a battery. In fact, they show a bunch of batteries. Doesn't really matter, you just have to make sure your batteries total to 9 volts. So maybe you have like 6 1.5 volt batteries, or maybe you just have one 9 volt. If it's an AC power supply like the plugs in your home, the symbol for that is a circle with a sine curve in it, and you label it with voltage and you label it with hertz. Again, its purpose is to supply electricity to your device. We'll learn later in the year what hertz actually stands for. Resistors. The symbol is a series of jagged lines. So think of it like a wire, except there are obstacles in the wire to slow down the electrons. You label it with the number of ohms. And again, the purpose of the resistor is to limit the amount of electricity getting to certain parts in your circuit. You'll notice there's a bunch of resistors needed: 100 ohms, 10,000 ohms, 47,000 ohms, and 4.7 kiloohms. We learned about variable resistors. These are like your controls for volume, brightness, speed. They're drawn just like a normal resistor, but they incorporate an arrow in there. They are labeled with the maximum resistance. And the purpose again of the variable resistor is to let the user control the flow of electricity. We have voltmeters. They're a circle with a V. You might find them in your car to monitor the voltage of the battery, and that's their purpose. They monitor voltage. Okay? The symbol again, circle with a V, and there's no label for these. You have current meters. They're called ammeters. They're a circle with an A. Again, this is one that you might find in the car dashboard, and it lets you know how much current is either entering or leaving the battery at any given time, whether or not your battery is charging or discharging, okay, and how quickly. Again, there's no label for these other than the symbol, which is your circle with the A inside. We have capacitors, which we learned about before, lots of different types. Here's a cylindrical type. When you draw them, you'll either see them as two parallel lines of equal length, or you'll see them as one vertical line and one curved line. Either way, you label them with the amount of farads, and you label them with the maximum voltage before they break down. Again, the purpose of the capacitor: store energy, store charge, or create an electric field. You'll notice this has lots of capacitors in it. Most of them are labeled, like this one, 3.3 picofarads. This one could be any capacitance between 2 and 5 picofarads. We have solenoids. We haven't really learned about these yet, but these are coils of wire that generate magnetic fields. I'm not too worried about them right now, but I just wanted to have them in there so you had a complete set of schematic symbols. It's labeled in a unit called henries, which again we'll be learning about later on. You'll notice on this motherboard there is a solenoid, and you'll notice in our circuit there is also a solenoid. Fuses are important. Fuses are just wires that will burn up if too much current goes through them. So they protect your device from getting too much electricity. Unlike the resistor, they don't limit the current, but if the current exceeds a certain value, the fuse will burn out instead of ruining your more expensive device. You label the fuse with the maximum current that it can handle before it burns up. In your home, most of you probably don't have fuses anymore. You have circuit breakers. They have the same purpose as the fuse, and that is if too much electricity is flowing through, they will shut the circuit down. Circuit breakers look like this, and they are labeled with the maximum current before they break. If you go in your basement, it will probably tell you 15 amps, 30 amps, 60 amps, how much current you can draw before you blow a fuse in the different rooms in your house. We have these things called grounds, okay? In your outlet, this circle here is the ground hole, and that is connected into the earth. We'll learn more about grounds later, but the symbol for ground can either look like this or it can look like that. It doesn't have any other type of label, and its purpose is there to shunt off extra electrons into the earth should the need arise. Here is the ground spot on a helicopter, and again in your car, oftentimes the negative terminal will be grounded to the body of your car. Okay, again, we'll talk more about grounds later. Antennas are there to broadcast or pick up some sort of signal, and this is the way an antenna looks. It's usually not labeled. You'll notice I have an antenna to broadcast to the radio for this device that we have been looking at. There's devices called transistors. They look like this. They will be labeled with some sort of code that you could then look up online to tell you exactly what that transistor is doing. And this transistor, in fact most transistors, are there to amplify signals. This code will let you know exactly how much it amplifies and exactly what conditions it can work under. We are not worried about that much at all right now. I just wanted to show you, here is the transistor for our broadcaster. And again, this is the code so you can figure out exactly what that transistor's conditions would be best for. We have speakers. This is how they look. Again, they turn electrical energy into sound energy. And oftentimes they'll be labeled by how many watts they can produce. Lights, this is the symbol. They turn electrical energy into light. And again, they're usually labeled with the number of watts that they produce. We have switches, lots of different types. A simple on-off switch is called the single throw. We have like the doorbell switch that you might have in your home, where when you push it down, you make a connection. It's called a momentary contact, because as soon as you let go, this thing pops back up again. We have a momentary contact that's on until you push it, and that will shut off the electricity. So in my classroom, I have one that you push, and it shuts everything down if there's some sort of emergency. You'll see these on things like escalators also. If there's an emergency, you push it down, it breaks the contact, and everything shuts off. We have a double throw switch, which is the kind of switch where you can turn something on and off in different locations. We'll learn more about this one later. For our purposes, this is probably the most important switch. Simple on-off switch. Okay, we have photocells, and these things are used to control something based on light. So this photocell looks like a resistor, which it is, but it varies based on how much light is hitting it. So lots of light will change the resistance of this photocell. We could then use that to have something come on when it gets dark, or we could have it have something come on when it gets light, depending on how we hook it up. So brightness controls resistance. We have a thing called the thermistor, which is a resistor that is controlled by temperature. Different temperatures will create different resistances. And again, we can have this turn something on and off with temperature, or we can have it just determine the temperature based on how much resistance there is. Again, these usually don't have any other labels other than the picture. Okay, so that's all we're going to be doing for today. Again, I wanted to give you a picture to remind us of the time we were together. So all you have to do today is take a picture of your notes and attach it to the Google Classroom and hit turn in. I will see you all again online tomorrow.